हेलो फ्रेंड्स, वेलकम टू द सेशन अगेन। आज हम बात करेंगे डेरिवेशन ऑफ बाइनोमियल थ्योरम एंड पास्कल ट्रायंगल। बट बिफोर कमिंग टू द थ्योरम itself, we must know about what are binomials, what are binomial coefficients, and the relation between coefficient of binomial expansion and Pascal triangle. Now let's begin the session. First of all, what are mononomials and what are binomials? Mononomials versus binomials. Here are some expressions. For example, x plus 2x, y and y square plus 2y square. These all are mononomials because mononomials means the expression which have only single term. So all these expressions have single term. X and y are single term and x plus 2x can be written as is equal to 3x. It is also a single term, hence mononomial, and this is also equal to 3y square, hence the single term and the mononomial also. But in these type of expression, these have two terms. Say, for example, x plus 2x square, y plus 3, y square plus 2y. These both the terms are from different family, that is, one is from x family, another is from y, and in this case one is from y family and another is from constant family. So these type of expressions are known as binomials because binomial means the expression having two terms. So these are all the binomials and these are all the mononomials. अब डिस्कस करते हैं बाइनोमियल थ्योरम को. व्हाट इज बाइनोमियल थ्योरम? It is a way of expansion of expressions like x plus y raised to the power n. हम सबको पता है x plus y whole square is equal to x square plus 2xy plus y square. Similarly, we can expand the x plus y whole cube and x plus y raised to the power 4. But what if the power is so huge like 540? In this case, we cannot expand this equation and hence we have to make use of binomial theorem. Binomial theorem is a derived theorem. अब हम देखते हैं कि how to derive the binomial theorem. For this, we have to observe all these expressions written here. First expression is x plus y raised to the power 0. We all know that any number having power 0 is equal to 1. And the second expression is x plus y raised to the power 1. In this case, we can write it as x raised to the power 1, y raised to the power 0 plus x raised to the power 0 into y raised to the power 1. Similarly, we can expand these expressions also. Here are some things which we have to observe. In this expression, the power of x is decreasing when we move from left to right, but the power of y is increasing from left to right. So, similarly, in this expression also, the power of x is decreasing when we move from left to right and the power of y is increasing. Similarly, in this expression, so we can conclude from here that when we move from left to right, the power of x decreases but the power of y increases. And one more thing that we should observe from these expressions is that in the first term of all these expressions, we give all the powers of expression to x and we give 0 to y. In all the expression, you can see this. Here the power of the expression is 2. We give x the whole power 2 and y to 0. And similarly, the 3 is given to x and y to 0. And in the last term of each expression, we have given all the power of the expression to y and x to 0. Similarly, in this case, the power of this x plus y whole square, we have given all the power to y in last term and we have given the 0 to x similarly in this case. So here are two things. we should observe from these expressions that when we move from left to right, the power of x decreases but power of y increases. And the first term, the first term of each expression, x has all the power of the expression, and the last term has, in the last term, y has all the power of expression. From these observations, we can write the general form of binomial theorem. This is the general form of the binomial theorem. X plus y whole power n is equal to nc0 x raised to the power n y raised to the power 0 plus nc1 x raised to the power n minus 1 y raised to the power 1, and so on. And the last term is ncn x raised to the power n minus n y raised to the power n. In this expression also we can observe the previous observations, like the first term, in the first term x has all the power of the expression and y has 0. Similarly, the power of x are decreasing from left to right, n to n minus 1, n minus 1 to n minus 2, and last term is n minus n. And the power of y is increasing from 0 to 1, 1 to 2, and the last term has all the power. Here, these nc0, nc1, nc2, nc3, and ncn, these are known as the binomial coefficients. These are known as the binomial coefficients. बाइनोमियल थ्योरम की जनरल फॉर्म से हम एक बात और ऑब्जर्व कर सकते हैं, दैट इज द binomial coefficient, that is nc0 and x raised to the power n minus 0 y raised to the power 0, that is the nc0 will have the same value which will be subtracted from the power of x, and it will be same power of y, that is when nc0, then the 0 will be subtracted from the power of the x and the power of y will be equal to 0. Similarly, in this case, when the coefficient is nc1, then this 1 will be subtracted from the power of x and this 1 will be the power of y. Similarly, in this case, you can see that the nc2, this 2 will be subtracted from the power of x and the 2 will be the power of y. Similarly, in this case, and also in the last term, you can see that ncn x raised to the power n minus n and y raised to the power n. This n will be subtracted from the power of x and this n will be the power of y. Using this general form of the binomial theorem, we can expand any expression. For example, x plus y raised to the power 50. Here n is equal to 50. So we can write this. The binomial expansion of this expression is 50c0 x raised to the power 50 plus 50c1 x raised to the power 49 y raised to the power 1 plus 50c2 x raised to the power 48 y raised to the power 2, and the last term is 50c50 x raised to the power 0 and y raised to the power 50. You can see that here that the power of x is decreasing but the power of y is increasing, and the same value which is written in the coefficient 50c0 is subtracted from the power of x. Here 1 is subtracted from the power of x and here 2 is subtracted from the power of x. Similarly, in the last expression, the power of x will be 0 and the power of y will be the 50. One more thing from here that we can observe is the sum of power of x and y in each term will be the power of the expression, that is n, and it will be same for each term. For example, for this term, the power of x plus y is equal to n minus 0 plus 0, that is equal to n. Similarly, for this term, the power of x plus y is equal to n minus 1 plus 1, that is equal to n. Similarly, for all the terms, we can say that the sum of power of x and y will be equal to n. अब हम डिस्कस करते हैं पास्कल ट्रायंगल. Pascal triangle. To understand the Pascal triangle, we again observe these expressions. That is, x plus y raised to the power 0 is equal to 1. The coefficient here is equal to the 1. Similarly, in this expression, the coefficient of x and y is 1 and 1. And in this expression, the coefficient of x here is 1, the coefficient of xy is 2, and the coefficient of y square is 1. Similarly, in this expression, the coefficients are 1, 3, 3 and 1. So, these are what we can observe from here, that these are the coefficient of these expansions, and these coefficients forms the Pascal triangle. Pascal triangle can also be formed as, here the one will shift on the borders like this, and the middle terms are written by adding these two terms, that is 1 plus 1 is equal to 2. Similarly, 1 plus 2 is equal to 3, again 2 plus 1 is equal to 3 and 1 here. So, if I have to write the coefficient of x plus y raised to the power 4, we can write it as the 1 will be shifted here, the next term will be the sum of these two terms, that is 4, the next term will be the sum of these two terms, that is 6, and the next term will be the sum of these two terms, that is 4, and the 1 will be written like this. This is the coefficient of this expansion. Similarly, we can write the coefficient of x plus y raised to the power 5, and these will be 1, the sum of 4 plus 1 5, the sum of 6 plus 4 10, the sum of 6 plus 4 10, the sum of 4 plus 1 5, and the 1 will be written like this. These are the coefficient of the expression of these x plus y raised to the power 5. Hence, this is called the Pascal triangle. Now let us talk about the coefficients of binomial expansion. In the previous slide, जैसा कि हमने देखा कि this is the general form of the binomial theorem, and NC0, NC1, NC2, NC3 and NCn are the binomial coefficients. बात करते हैं कि ये जो coefficient है वो कैसे find out करते हैं. Here we have written the coefficient in this form, and this forms the Pascal triangle. Again, this 1 is equal to NC0. Similarly, this 1 is equal to NC0. Here, in this case, the n is 1 because the power of the expression is 1. So, 1C0 is equal to 1. Similarly, here n is equal to 1. So, 1C1 is equal to 1. Similarly, in this case, the n is 2. So, 2C0 is equal to 1, 2C1 is equal to 2, and 2C2 again equal to 1. Similarly, for this expression, here the n is equal to 3. So, 3C0 is equal to 1, 3C1 is equal to 3, and 3C2 is equal to again 3, and 3C3 is equal to 1. So, the Pascal triangle is made up of the coefficient of binomial expansion, and binomial expansion's coefficient comes from the Pascal triangle, and these terms of the Pascal triangles are nothing but the coefficient of these expressions. So, I hope आपको समझ आया होगा कि एक एक्सप्रेशन के कोफिशिएंट्स कैसे पास्कल ट्रायंगल फॉर्म करते हैं, एंड द पास्कल ट्रायंगल आर नथिंग बट द कोफिशिएंट्स ऑफ बाइनोमियल थ्योरम. आई होप आपको ये लेक्चर समझ आया होगा. थैंक्स फॉर वॉचिंग.